earlier versions, what the developers did actually, they defined four interfaces as internal interfaces, which cannot be accessed, by outside, right? So I think it was a very good design decision. The attack surface would have been much higher if they had these four services as public services. So the measurement results of 3 versions conform to the expectation. And what you can also do with the tool is you don't want to see boring text, showing you the attack surfaces at different layers, class, package level, method level, etc. So you can really see for example, which class of the entire application has the highest contribution. Or you can see, for example, show me the top 10 contribution, because if you have, let's say, million lines of code, so you don't have the time to analyze the entire code. You want to really see, so where are the problems, right? So you can see the top 10 contribution, and then when you do refactorization, for example, or when you try to improve your code, when you want to come up with a new release of your code, and you can really focus on this part of the code. And you can also look at attack surface measurement at the method level. So you can see, for example, so what is the contribution of the data store, what is the contribution of the parameter, input parameter, and other systems. So potential user scenario. So the question is now, okay, let's say, we were able to understand the abstract method. We instantiated it for Java and did an experiment in a Java-based enterprise application. So how can we use this tool? Right? The tool can be used during the design and implementation to measure and reduce attack surface. The developers of software vendors can use this tool. Of course, the customers, because customers are customizing the code. And you can also use the tool during the testing phase, in particular during the code inspection. Because imagine you have now 3 million lines of code and you want to do code inspection. Usually the software vendors are doing code inspection in order to catch the performance-related, security-related implementation bugs and defects. So, but they don't have the time to do the code inspection on the entire code. That's why they select a portion of the code. What you can do is actually you can run the tool on the entire 50 million lines of code and then see where you should start with the code inspection, because probably this part, the top 10 contribution of your software, has probably will probably have more security issues in the future because you have more methods dealing with input parameters and communicating with outside, etc., or have some sensitive methods, for example, checking authentication, authorization, etc. So you can also use the tool in the deployment phase. So we don't do it with the current tool, but I can imagine that for example, each time a customer's system administrator configures the application and changes the configuration, he can see, okay, now with this configuration I have the optimal or the minimal attack surface, right? So, during the maintenance, if you add some patches, for example, you can also see, does this patch increase the attack surface? Because if you found a security bug and you add a patch to your software, it will be great if the patch wouldn't increase attack surface. It probably solves the problem, removes the bug somehow, right? But it may open some other channels. So that's why the ideal case is, adding patches in a way that the attack surface doesn't increase. So what we believe is, we believe that the complete risk management requires the combination of code quality and attack surface reduction. I'm happy that we started with the collaboration with CMU, and then we are now, we have a now better understanding what attack surface measurement will mean in the context of enterprise applications. And currently, we are exploring the use of attack surface measurement in code inspection, as I mentioned. I think this will be a great, let's say, tool in order to do the code inspection in an efficient way. And so we did analysis in Java-based applications. We plan to extend the work to JavaScript and ABAP. ABAP is SAP's proprietary, that's a database-oriented language, and most of the application or logic has been written in ABAP. And we also need to find the kind of range, because so you have seen these graphics and numbers. So if you look at this tool, it is possible to give a threshold, because with each threshold you will see different numbers. So the question is now, what is the threshold? You won't be able to probably find a number like if it is under 50, then you have a less attack surface, or it's acceptable. You will probably need to come up with some ranges, right? This is the kind of optimal acceptable attack surface. And we also need to prepare kind of attack surface reduction guideline, because the tool is measuring the attack surface. Now the question is, once you have measured the attack surface and it doesn't have an acceptable range, how do you reduce it? Because reduction means you have to turn off some services which are not required, right? So because you may not guarantee this always, because if you talk about applications having millions lines of code, so we may have some services and methods, we have implemented them, but let's say 80% of the customers don't really use them. Might be the case. So the question is now, shall we turn on these services when we deploy the applications in all customer environments, or shall we just turn on them or turn off them if certain customers do not require it? So we also need to do further research. Like it will be interesting to do kind of research in order to understand, can we do attack surface analysis in the absence of source code? Because as Elisa mentioned, so it might be a little bit expensive to do a measurement. So if each time if you need to look at the code and annotate, etc. So I would like to thank our collaborators from CMU. Partush Manatada is a PhD student. He actually recently defended his PhD, and Janet Wing, advisor. And I also had an intern working with me at SAP Research. He is now back to Colorado State University. He still works for us, and he helped us implementing the visualization tool, and also several SAP Research and product teams. Their help was really good. Thank you very much.
Okay.
So, any questions?
I would like to thank Yuecel for the very interesting talk. So, if there are questions, okay, go ahead. Okay, let's do this. Okay, go ahead. You have to talk into the.
Okay. During the measurement of the potential risk, you give weight for different input resources.
Right.
But at the beginning of the talk, you said it's hard to measure the risk because the situation and the environment will change. But how do you validate the number you give to different kind of?
So I mentioned that we looked at the threat modeling which has been done for the service. This means when you do the threat modeling, you see, okay, these 5 types of threats might happen, or had happened in the past, and you look then at how these kind of vulnerabilities, how these threats really work. And if you have, for example, if you had more SQL injection problems, or if you think that you will have more SQL injection problems in this type of applications, then you see how SQL injection really works. And if SQL injection uses input parameter or misuses input parameter of a method, then you give a higher rate to this certain input parameter of the method. So somehow you need to understand the challenges, threats around a service. Otherwise, you really need to have, you have to feed the tool with some weights which make sense for individual applications. So there won't be any attack surface measurement tool or approach which will work for all kind of applications. So otherwise, we have something like this, automated static code analysis tools. You can buy them, or you can hire companies to do this analysis. They don't find everything. They don't find everything because they don't really understand the semantic of the code. So, or at least most of them don't understand. So you have to understand the threats around the service, and then give the weights based on the possible threats and how these threats happen.
So you kind of predict the possible kinds of attack.
Right. Either you predict it, okay, or you look at, for example, earlier versions, deployments of earlier versions in customer environments, and or other kind of application